Hey everyone, Blake here, and I have just upgraded all of the source for the simplest scenario tutorials up to version 0.4 of Unity ML Agent. So I'm going to give a quick tour through so that we can look at these, understand what's going on in them, and let people play around with them a bit. And then I'm also just going to give some tips about what changed between 0.3 and 0.4, because not much changed, which is really great. That means that the APIs and stuff are getting locked down, which means more and more of what we do in earlier versions is likely going to be able to carry over as the tool set matures. So that's really good news. So let's go over to our main screen here, and we'll see, again, we are back in version 0.1, the simplest problem that I can think of for machine learning. You know, if you're having trouble getting this to work, that means you're having issues with your pipeline or your tooling or something like that, because this problem is supposed to be dead simple. Put the white marker on the red target. That's all we're doing. So again, we have a main camera, we have a directional light. These are standard Unity things. And then we have an academy, which holds a brain, and we have our game environment. So the academy, I have created something called a generic academy. I use this in a lot of my examples. Basically, the generic academy is there just to be, you know, you need some kind of academy, but if you're like, I don't want to get into academy training just yet, I don't want to do anything crazy like that, this is all there is to a generic academy, is we just implement the academy, and so the academy, or you set an academy step right there. Couldn't get much simpler than that. And then, so that's what's in the academy. The generic brain is, again, a generic brain. This is, so if you right click on it and edit script, this is going to open up, again, trying to keep things as simple as possible. This is off of, right, we're not subclassing anything, right? So the generic brain is just exactly as it came out of the ML Agents code base. So you don't actually have to do anything there. Let's see, what else do we need? Right, so that's just the normal brain script. So you create a game object, you bring in the brain script, and I call it the generic brain because I use it for a lot of problems. And the generic academy, again, just a game object with the generic academy script. You saw how short that was, no biggie. All right, so the game environment itself, again, so we have one game object up top that's kind of controlling everything, and then we have two components. We have the marker and we have the target. So you move the marker up or down to reach the target. That's the entirety of the game. The marker and the target are just standard cubes, right, with no behaviors directly on them. They have renderers, they have colliders so that they interact with each other. I think the fanciest I got was I clicked on the target that it is a trigger, right? So that they're not physically hitting each other, that the marker will go inside the trigger and trigger it and say, hey, you know, you got a reward by entering the trigger zone. So there is all of that. And then in the generic, the simplest agent will have, and you'll see that code down here. Again, it's fairly straightforward. This is the most work of anything. Not that that's saying a lot. Again, really simple baseline, right? We have a game object, which is the marker, which is the target, starting height, minimum and maximum, so we randomize the location of the target, the marker speed, how quickly does it move up and down, distance to earn reward, how close do you have to be to the target to earn a reward, and then how many points do you earn when you get there. These default values aren't that great, so if you use this, be sure to actually check out the values that I have in the scene, because those are going to be better than my random guess first shot values that are in the code here. Initialize agent, I bet you can figure out what that does. Agent reset, so this is just saying, hey, when the game resets, where do you put the marker and the target, right? And so we have these randomized positions saying, hey, ran somewhere between the starting height minimum and the starting height maximum, that's where you put the marker. Collect observations, right? How far, there's only one observation that happens in this entire scenario. How far is my marker from my target? That's it. And so you just add this to the observation, right? How far am I from my target? And then agent action. So this is every step of the way. The system is going to try to figure out how to take an action. And so the first thing it does is needs to make sure that the brain is in the proper state. And then if it is, we basically pull the action from the brain. We clamp it so that it has an upper and lower bound. And then we take that action again. So that action from the brain is going to be from -1 to 1. So all the way down to all the way up. We multiply that by our marker speed, and that tells us how much we should move the marker, and then we move the marker. And that's it. Oh, yes, and if the marker is within range, then we add a reward. So basically what happens, you start your game. Here, let me switch this generic brain over to player. Right, and I believe I should have these keys bound. Maybe not. Nope, I don't. Nope. Okay, so I didn't reset those when I upgraded to 0.4, so I should probably do that before I push everything up. But the whole idea is the game begins. The brain takes a look at the scenario. It makes an observation, right? What does it observe? Well, it observes whatever we tell it it observes. So in this case, it's this collect observation. So that's an array of values. What does it observe? And it doesn't know the meaning of each of those values. We're just giving it a bunch of numbers and saying, oh yeah, we're just going to tell you a bunch of stuff you figured out. Well, in this case, a bunch of stuff happens to be only a single value, which is how far is the marker from the target. So we collect observations, feed it into the neural network. The neural network spits out an output, which is an array of floats in this case that just says, all right, based on those observations you gave me, these are the actions I think we should take, right? And so then we take those actions, we interpret them, and in this case, we're taking them, we're saying, okay, whatever action you say, we're going to correlate that to moving in the y-axis up and down. And then after we have done the observation, fed it into the black box, which is our neural network, gotten an array of actions, interpreted those actions, then we evaluate performance, right? And so that's where we set a reward and or determine if the game is over, if the game has that. In this case, we're just determining a reward. And then we feed that back into the system. And so the items that earn reward are trained up and they're rewarded, and you're more likely to do things that are rewarding. And over time, you build up a relationship that says, hey, when I reduce the distance to my target, I am more likely to get a reward, and that's how it learns. So that is basically everything there is to the simplest scenario. So what's changed from previous versions of the Unity ML agents? Not a whole lot. We needed a new using statements up top, and that was pretty much it for this one. Now in the next environment, this is where I bring in multi training, where instead of just playing one game at once, I'm playing 20 games at once, or could even play more games at once. And so the whole idea here is that between evaluations, you build up more experience by trying more things. And it does help improve the performance of training. There were a few differences. So you'll see in a lot of the Unity examples that they've already gone ahead and prefabbed their environment, and they've instantiated it, and so you'll be looking at 12 versions of the same game. Personally, I find that a little messy and clunky. I'd rather have a smarter environment like this one, that instead of having them all there, I have one master one, and then I make duplicates of it at runtime, and it arranges them in a line. And so you can see that's what's happening here. Before, I was able to take that environment and have it just prefabbed with no changes. However, there is a newer thing in that I've noticed is with the prefab, if I start with the prefab on, right, so if I start with the prefab active and hit play, you'll get a bunch of errors in the console, right? Now, it turns out that these errors aren't really important, but you do get a bunch of errors in the console, and it does mean that if you were ever going to move to visual observations, that this would be something of a problem. So I figured, all right, if by starting active is a problem, then I'll just deactivate it. Of course, I also had my initial game deactivated as well. Now what happens is if you start with no active games, then the new version of Unity ML Agents looks at it and says, oh, there's no brains, I'm done. Right? So what I found is really the best way to do this is to have kind of n+1 games. So you start with one, right? You have your base case here, and that single one is active, and then you make a prefab out of it, and then you mark that prefab as inactive, and then that's when you use this game creator script, right? And so this is just saying how many of them do you want, what is the prefab of your game, how much distance do you want between them, and then what is the brain to assign to them when they instantiate. And so by having the active kind of prototype game, right, the root game that we made a prefab out of, and then making the prefab and then marking the prefab as inactive, it will actually train correctly and you don't get any errors. In this case, it's going to throw one error because my brain is set to external. But, it doesn't get those camera errors that we were getting before. That's pretty much it. Everything else seems to work just fine. So again, for those who are newish to this, so simplest scenario, make sure that you understand this and are very comfortable with it before you move on. After that, we just get into prefabs, no big deal. We add gravity, which increases the difficulty and makes it a bit more realistic, right? And then we start getting into continuous rewards. Now that curiosity is a thing, I'm not sure if continuous rewards are quite as necessary as they once were, so I'm looking forward to doing some experiments with that soon. The obstacle, this is where we add a floor. All right, so we want to be able to get to the marker without crashing. And then the 3 inputs, that's when we actually make the game in 2 dimensions, right? So we have a left, a right, and a thrust. So that is where we are currently with our ML agents. So this is just kind of getting everybody caught up on what the basics are and what it looks like. So from here, we're going to be getting into, I think, more advanced topics, varying things a little bit. I would like to do some stuff with visual observations. I'd like to explore curiosity. I'd like to explore movement. There's a whole bunch of interesting topics that I think we can cover. So we'll be moving into that very shortly. Thank you for watching. Any questions or comments, feel free to toss them down below. I will happily answer them as much as I can. I am also going to make sure that all of this code is up on GitHub. And there is also a Patreon, which I will link below for anybody looking forward to support this video series. Thank you very much, and happy learning.